Vectors. Yes. Should we do this at the end then? Let me just do this stuff. We'll do it. Okay. That one's definitely going to be in your exam. Give me an answer. Keep in mind, extension 1 is only a 1-unit course. So less content. Should be technically easier. Should be. You're only finding that because of you're doing a lot of technical questions. You realize you do examples as well. Examples.
Which one of those?
Done? What's your answer, Mariette? You got B. Let's see. I got dn on dt equals k, and then obviously aekt. Aekt is equal to n minus 750, so the answer is actually D. I didn't think it was right. I was looking at it. Be careful. Any questions? Like I said, 100% will be in your exam. Are you ready for it? Vectors. All right, 7. Which polynomial? You can't do 8. Just 7. Which polynomial has a multiple root at x equals 1? Multiple roots, what do we do? Of course, p of 1 is equal to 0, but also p of... Ooh, there we go, we found a weakness. Derivative, p dash of 1 also needs to equal to 0. Multiplicity, it's got the original and the first derivative must equal to 0. Go. Sub it in. 1 plus 3 is 4. That one works. 1 plus 2. This one doesn't work. Sorry? Discriminant. But you can't because these are cubics. 1 plus 2 is 3. This one also doesn't work. So it's literally just between A and B. P dash 3x squared plus 6x. And the other one is for A. For B is 3x squared minus 3. Sub in 1. This one gives you 0. This one gives you 9. 100% will be in your exam. See, you're going to hear me probably say that a lot in Extension 1 compared to the Advanced, because in Extension 1, whatever you learn is tested. In Advanced, you learn 100%, you get tested on 60%. Extension 1, Extension 2 is not like that. Whatever you learn is tested. Alright, slope field, not for you right now. The graph, yep, that's for you guys. Your favorites. You don't need to know the answers at the bottom. You got to try to draw it yourself. Y equals 1 on f of x in absolute value. Okay. We know that 1 over f of x intercepts. 1 over 2 is a half. You can't say I forgot asymptotes. Did you say I forgot asymptotes? You can't. Because that's the whole point of this. And then these ones are down here. These ones are here. And then what does the absolute value do? All the negatives become positive. So the parabola on the top doesn't change. And that's your answer. So let's have a look. B looks good. The answer is B. Oops. Yeah. Ugh. Did you get that out? Oh yeah. Good work. Clean. I like it. All right. Any questions? Let's see what we can do from here. You can do A, if I'm not wrong, and you can do F. And that's it. A and F. Oh, a standard die is rolled 5 times. What is the probability of rolling a 4? At least 2 times. That's binomial probability, which I think is year 12. Well, not yet. Even though we can, it technically shouldn't be in your exam. Question 11A. Okay, first answers, what do we have? 9 people are arranged around the circular table. How many people can that? 8 factorial. If they are seated randomly, what is probably that 2 individuals, Lewis and Clark, are sitting next to each other? 7 factorial times 2. Is that right? As your number of ways. And then you have to divide it by? Oh, don't tell me you didn't get the mark. Probability. You don't do it over 8. I'm saying if you don't do it over 8 factorial, you just lose. What a waste of time. Question 11, nothing. You got nothing for it. All right, F. Any questions? No, I didn't think so. All right, F. F. Hopefully you guys are doing it my way, because if you're going to do it the other way, that's going to overkill it. Okay. And test. Say that again? That's actually okay.
Oh, probably 2.
Also, probably -2 now.
2 weeks away from 1 so 2
Divide by 2. Yeah, you bring everything to over, yeah.
And then you get a quadratic, but then you solve.
What are you doing? Then divide by 2, you bring the 2x over, you subtract the 2x. Show me from there.
Oh.
Yeah, that's correct. That's what we can do. Expand, bring this over to 0. All right, let's do it. 2x equals x plus 4, x minus 3, x squared minus 3 plus 4 minus 12. Everything to one side. X squared 1 minus 2 is minus 1. Minus 12 equals 0. Second.
And then you get -1.
Okay. Yes, I do. Of course. Yeah. Okay, and then you do end up with x minus 4 and x plus 3 equals 0. So x equals to 4 and x equals to negative 3. But also you know that x cannot equal to 3. So then we have our number line. Then we've got negative 3, which you can equal to. We've got 3, which you can't equal to. We have 4, which we can equal to. Isn't it funny how sometimes you guys, like for example, focus on functions or you focus on other things, but like I keep telling you, you're not doing an exam on just functions. You're doing a prelim exam or eventually doing a trial HSC. Every single concept is important. So for those who couldn't get this out, I hope it reminds you, don't just isolate, ever. Next term as well, don't isolate topics, focus on everything that's in that topic. All right, test a few, just to be sure. Let's test x equals 0. That's 0. Is 0 bigger than or equal to 4? No, so that's wrong. So to me right now, my answer is this. But I'll double check it. You know, you've got time in an exam. Why rush? 3.5. Let's test x equals 3.5. So 2 times 3.5 is 7 on 0.5. Is that bigger than 7.5? Actually is, because 7 divided by half is 14. 14 is, I know this works. If you want to try negative 4, I'm sure it should work. It works? So negative 4, let me try. Negative 4 plus 4 is 0. 2 times, well, this side here is a positive number, bless you. It's a positive number. I know a positive number is just going to straight away be, yeah, it works. And that's it. So, bless you, final answer, x less than equal to negative 3, 3 less than x less than or equal to 4. Any questions? All right. Or next year, this year, 5 marks. Again, see how it doesn't matter if you went to 4th Street, you went to James Roos, or if you went, it doesn't really matter. The questions are exam questions, which is what I've always given you. They should be fine. Good luck. All right. Anyone got that yet? Right, on the right, I done. I is done. Okay, I should just be obviously, 2t, 1 minus t squared, 1 plus t squared. Just before I continue this, there's something that came to my mind. Again, look at the questions that you're seeing. You're seeing that they've become pretty repetitive by now, the amount of weeks that we've done it. Next term, the worst thing you could do is start with textbook questions again. Once you understand the concept, like once you guys understand, let's say, stationary points, forget about textbooks, do stationary points from exams. Jump straight to exams. Don't repeat what you just did, because you can see exam questions compared to textbook questions are very different. You've got to get used to them, and they're not that bad. Exams are not meant to be that bad. 3 times sine opposite over the hypotenuse minus 4 cos on 1 plus t minus 4. From the top of my head, that becomes this. Does anyone have any issues and actually wants me to do it though? No? Maybe? No? Nobody? Alright. Double A, hence solve. Well, that's not too bad. Again, don't forget you could have done double A even if you couldn't do I. Equals to 4. Multiply and solve for theta. They did, didn't they? I didn't even read. I just read 3 sine minus 4 equals 4. That's it. You're right. That equals 2. It says 0. Even easier. Do you see the fact that it's equal to 0? Yeah. So then it's just 6t minus 8. 6t equals 8. T equals to 4 on 3. 10 theta on 2 equals 4 on 3. Theta on 2 equals inverse 10, 4 on 3. Inverse 10, 4 on 3, 53 degrees. It does say leave your answer in terms of pi's. That means we want radians. So if your answer is in radians, then you got to convert your calculator to radian mode. Shift mode, and then 4. Then you do inverse tan, 4 on 3, which is 0.9293 rads, and you do all stations central, but that's going to get you too much for 360. But 180, pi plus 0.93. I'll just do it to make sure that you guys understand it. 4.07. I actually use pi as pi, not 180. And then, because you can't, that's in degrees. And then you'll get 0.93 times 2, 1.86 rads, and then 4.07 times 2, 8.14. But as I said, you're only going up to 2 pi. 2 pi is 6.2, roughly. So 8.14 is too large. The only answer you have is 1.86 rads. I was going to say something. I forgot. Oh, convert back to your calculator. Don't forget. So shift 9, 3 equals. The worst thing you could do is keep your calculator now back in rads. The rest of your exam, you're just going to get 0. It's happened. You guys laugh. I've seen trials that have just become 20% because of the radian mode. That's horrible. Have I got a text up here? Yes, you're going to write ones rad, ones. Yep, what was another question? You had another question about.
No, I thought your one was a 1.
Okay. Any other questions? All right, let's scroll down. The radius of the base of a cylinder is increased. Yep, that sounds. Yep, A, rates of change. I like it. That's meant to be. Exactly how it's meant to be. Differentiate. Stefan, I don't have an actual Sharpie. I've only got like, obviously whiteboard markers. But I don't think it'll work. It's only 2 marks, so it shouldn't be too hard, I think. Let's do it. The radius of the base of a cylinder, the radius, base of a cylinder is increasing at a rate of this. So what is that? What is that equal to? dr, because the radius is changing on dt equals 5 centimeters per minute. That usually tells you what it should be like. Centimeters is radius. The height of the cylinder is fixed. So it's not changing, it's a constant. H equals 30. And the formula for the volume is pi r squared 30. Find the exact rate of change of the volume. Find the exact rate of change of the volume. So you're trying to find dV on dt. dV, bless you, dr times dr on dt. Do we have a relationship between volume and radius? Of course we do, right there. dV on dr, 2 times 30 is 60 pi r. Radius is 10, 600 pi. Sorry? Yeah. They look the same to you? Times 5. Sometimes we do that with a V. Some people do that with a V to know that they're V's. I don't know if that helps. Because to me, sometimes that starts looking like my R as well. So, I don't know. But whatever. All right. Any questions? Radius is 10. Radius is 10. Radius is 10. R is 10. Radius is 10. R is 10. Easy stuff by now. Okay, go back. Oops, not this guys. These guys. Area, mathematical induction. That's going to be fun. Easy, 4 marks. Projectile. Differential equations, not for you. Vectors, not for you. End of exam. That's all that was extension 1, year 11. Because it's a 1 unit course. Doesn't matter if you're doing 4 unit or it's always going to be a 1 unit course, so they're going to test more year 12 stuff. Sydney Tech, closed. Let's go with James Roos. Because I think you're more all aware of James Roos, so let's just do James Roos. All right, let's start. 70 marks, 2 hours only for extension 1. Realistically, if you're ready for it, it should be done in an hour and a half. That's like the best case. Whereas with advanced, it should be done in about an hour and a half as well. So you should really be able to have another hour and a half. I'm talking about HSC. So, but in extension 1, you're pushing it. So your speed needs to be up there. Okay. First order. How many arrangements? Oh, that's easy. Look at that. James Roos. How many arrangements of the letters of the word Olympic are possible if the C and the L are to be together? 1, 2, 3, 4, 5, 6, 7, I think the answer is going to be, what, 6 factorial times 2?
Yeah. D.
D. Why does it feel like the answer is highlighted? Or does it just look like from my angle? Doesn't it?
Which code?
Yeah, it looks like...
Yeah, maybe you guys.
Oh, maybe it's my shade. All right, all right. All good. Part 4, question 4, sorry. Has a root of multiplicity 2. Has a multiplicity of 2. What does that mean? That means P of x and P dash of x both have the same root at x. If this has a root of multiplicity 2, then a possible value of k is which of the following? Possible value of k. Oh, okay. That's different.
You just work out without K and like all the values, like if you can't like 6. without
Absolutely,
K.
you got the right idea. Good job. Good. Annoying for a multiple choice, but good job. Stefan, it seems like you're reading it. Why?
I'm going to read it.
What is it?
You just started reading.
But why? You should just know that's it. Let's just start. P dash, differentiate it, make it equal to 0. Do the math. Don't know about the words. Here we go. P dash x equals 3x squared minus 12x plus 9 equal to 0. Divide everything by 3, just because I can. X minus 1, x minus 3, x equals to 1, or x equals to 3. The reason why they use this is because there's obviously a lot of different values. That's just any possible value. So it's going to be either at 1 or at 3. If it was at 1, it would look like this. 1 minus 6 is minus 5 plus 9 plus k must equal to 0. Correct? So therefore from that I can straight away say k equals to positive 4, so negative 4. So k equals negative 4 is a possible solution. What if it was at 3? I just want to see if they were going to be a bit annoying. 3 squared plus 18. You've got to always check. 27 minus 6 times 9 plus 18 is negative 9. The other answer would have been 9, which isn't there. I was hoping that they wouldn't put 9 in there, because then that would make things a lot more complicated. So, all good. Any questions? Understand the logic of multiplicity, and I did tell you what? 100%. You see? Second paper, different school, same year, 100% in the exam. That's a given. And if you don't see in your prelims, 100% in your half yearlies, your trials, your HSC. Reason why this will be tested, it was part of 4 unit. So there's a 100% chance it will be in your prelim. Questions? Girls? Where did I get? Which one from? 30, sorry? Minus 5 plus 9?
Yeah.
I subbed in 1 into here. 1 minus 6 is minus 5 plus 9. Why did I sub in 1? You don't know? Because at p dash of x and p of x, so the same x value must equal to 0. So when I said p dash of x, I found it was at 1 and 3. I'm subbing 1 back in, and it has to equal to 0. I subbed in 3 as well. It gave me 9, but I can see k's 9 is not an answer here. That's why it's saying a possible value of k. Because k could have also been 9, and this could have also had a root of multiplicity too. That's what it's saying. Okay. Any questions? Move down. The derivative of inverse sine. No, that's, well, maybe 4 unit guys can do that, but nobody else should be able to. That's next term. Vectors, low fields. That's vectors and vectors. Okay, well, I guess you can do, I don't know if you can do state the range. Let me just think about that. No, that should be next. Yeah, no, you can't do that. Oh, wait. No, you won't be able to because you need it from C. Sorry. All right, leave it. E12. No, E12. Finally, year 11. Yep. Year 11. See I and double I. Stop. Compare I and double I. Can you see what's happened? Just look. You can see what's happening? Good. Continue now. Back to I. It's good to keep realizing how they're all linked. So how to pick up a mistake it doesn't look long. It doesn't look long. I don't know how it's not long. You're saying to start. You haven't continued from that line. You're not. I can see what you're calling me. Again, you're trying to predict the answer without doing the math. But you just got to continue, and it's meant to work out. Yeah, that's the logic. You're meant to actually just do it. The fact that you're stalling, it's not gonna. Unfortunately, it's not gonna work long term. Like you literally draw this arrow, yet you didn't write it. You know what I mean? Why would you do that? You're gonna see my working out now. Here we go. Let's start. Left hand side. Tan. Tan theta plus tan 30 degrees on 1. Doesn't look right. This looks perfect, beautiful.
I think it's fine. It looks like to
Equals tan theta plus. Ah, that's what you mean. And the root 3 cancel out. Tan theta plus 1 on root 3. Divide 1 minus. See what I meant by, that's why you don't go over your work. When you go over your work, you're like, yeah, it looks right. And it does. It looks right to me as well. 1 minus tan times 1 on root 3 equals root 3, common denominator, plus 1 on root 3, divide root 3 minus tan theta on root 3, and then of course multiply and flip, equals root 3 tan theta plus 1 over root 3 minus tan theta. Yeah, you're not doing it.
I just kept writing it.
Yeah, but you didn't. You can't say that. I didn't even realize that, you know, you're just meant to continue writing and it just happens. It's just how it's worked. Okay, do the next bit, answer otherwise solve. So what's happened? Oh yeah, I see it. So this divided by root 3 minus tan also is tan 180 minus theta, isn't it? So therefore, what conclusion are you going to make? What conclusion are you going to make? I'm going to say they're the same. What conclusion are you going to make? Is what I'm asking. I just divided. These are the same now.
It is
A equals pi. No, hold on. Tan theta plus pi on 6 equals. That's the only conclusion you can make. The fact that these two are the same, you're going to say these two are the same. And that's the relationship you want, double A. Tan theta plus pi on 6. Does everybody get that at home as well? Equal to tan pi minus theta. Yes?
Yeah.
Okay then. Inverse tan, obviously you get theta plus pi on 6 is equal to pi minus theta. 2 theta equals 180 minus 30, which is 150 degrees. Be careful at this stage. Don't forget you had tan. So what you should be checking is your all stations to central for tans. 180 minus this answer. See how you guys just forgot about that all of a sudden with what I just did? So let me recap. Go back. So it looks good because most students get to that line, and because it's a different question to what they're used to, they usually forget their all stations to central. Every time you found an angle, like every time you've inverse tan, technically this side here, didn't we always go to our all stations to central and found the second angle as well? So you're meant to do 180 or pi, take away this. What's pi take away theta? Well, that actually just gives you theta, if I'm not wrong. Let's just say it again. Pi take away theta. Pi take away pi is gone, negative is theta, which will become no solution because you're going to get it equal to 0. So it didn't bother us in this case. Yes? Still with me? So I'm going to rub that out. You have to watch out for that. You can't just assume you can continue from where I left. All right, back to what I had, which was 30, 180, 150 degrees. That's 2 theta. What do we usually do with 2 thetas? We also add 360, but But it says from 0 to 180 anyways. Yeah, but then once I add, it's going to be a lot larger. And then whatever that gives you on your calculator. Any questions? 5 pi on 12. Any questions? No? That wasn't too bad. Just the one you've got to watch out for is the cases of all stations to central working out. Because if this was obviously 2 theta, it would have worked. And you would have no solutions. You've got to watch out for that. You can't just assume you can inverse tan and cancel them out, and that all stations to central doesn't work. Exponentials and logs, yeah, you can cancel them out, no problem. But with trig, because they go on forever, you have to have that idea. All right. Any questions? No? We're good? A tank contains saltwater solution consisting initially of 20 dissolved. Fresh water is being poured into the tank at 3 liters per minute and the solution is flowing out at 2 liters per minute. Show that Q, the amount of salt at times satisfies the equation dq on d2, dt equals negative 2q on t plus 10 plus t. Where Q is the amount of salt. Technically you can, but then you won't be able to do the differential equation bit. So more U12. Oh well. C. Yep. That's for you guys. What are you thinking of using for CI? What am I thinking of using? I'm thinking that one. Is it wrong? I don't think so, but that would be my instinct. What are you guys thinking of using? Of like sine 2 theta, double angles, that one? So you're saying you want to change sine 2 theta to 2 sine theta cos theta? No. But I don't think so. No. Which one? The other one? The half. That's the one you've got to use. You remember we did a similar case to this one here with the 3 cases? We did the first 2 first, and then good luck. And I think it was also times by 4. Yes, if you guys went to James Riss, you would have already seen this question before now. Say it again. James Riss is free. It's a public school. Yeah. Yeah. That's a public school. It's still government funded. Well, not for free, I mean, but yes, it's correct. It's a government school. No, it's a government school.
Wasn't every school technically funded already?
Correct. Yeah. They just use it for other things, like fingerprint doors.
$14 million.
And maybe a helipad for your school. I think that's next.
Swimming pool. Yeah. Actually,
You guys are getting helipads.
we had a helicopter land on over.
Yeah, I think he wants a helipad, your principal.
Actually,
Yeah.
it looks so small. Every day he's in a new car.
I love it. All right. So which one are we going to use? Which one? Sine. Who's got the formula out for us? Sine.
Half sine A plus B plus sine A minus B.
Sine A plus B minus
Plus.
Plus.
A minus B.
A minus B. All right, let's do it.
Or
You have an extra sign that
Why are you saying no?
Sin A, sin B, yes.
Sine A, sine B.
We need half cos A minus B minus cos A plus B.
Oh, it's cos causes.
Yeah.
Well, that's fine. Because what's cos and a sine make? Cos A, what's cos A, sine B make? Sine, sine? Okay, no stress.
I'm tricky.
Ready?
What?
One at a time.
Yeah.
All right, wait, you guys are confused. So wait, let's get the formula sheet out so you guys can see. Where's this formula sheet? Is there a formula sheet at the end of this paper? You send one? I just want that bit, that's all I want. You send it to us? Unless one of these guys know it, have memorized it. Send the link. You guys get it out. Oh, there we go. All right. Copy. All right, here. Look. Can you make it any larger? So ready? Goes. What we said sine makes causes. And then it's like, oh no, that's wrong now. I was like, that's still okay, because when this is a cos, don't I have another sine that's going to be multiplied by? So what does a cos and a sine make? Sines, which is what we needed. So it's actually right. Don't stress. Sine A, sine B. Let's do it. So sine 3 theta, sine 2 theta
The middle is really minus.
equals half minus, thanks, cos 3 plus 2 is 5, minus cos 3 minus 2 is 1. Any questions there? 4 times a half is 2, and then you have 2, technically, multiplied by cos 5 theta times by sine theta. Can everybody see the expansion there? Or do you guys actually want me to expand? Sine theta, cos theta. Something like that. Can we see that? Wait. This is this. So then half times 4 is 2. Then it's just this bracket multiplied by sine. Can we see that? You can do it your own way. If it was too fast, do it slower. I don't care. Now look what you just found. 2 sine cos. 2 sine theta cos theta is sine 2 theta. Ah, that's a shame, it's minus.
It's
Oh, well.
supposed to be on the other way around.
What do you mean?
It's supposed to be A minus B.
Oh. How come you didn't say it? You told me I got okay.
I was leaving it up to Rosie. She likes to proofread.
I was relying on you. I was like, oh yeah.
That's theta, that's 5. But it's alright, easy fix. There you go. That's 5 and that's theta. That's 5. That's 5 and that's theta. It's not so much the problem. I mean, the math right now is easy. I don't think we're worried about the math. You guys can continue it yourself. It's more that first initial step. That's it. But what about this bit here becomes 2 sine theta cos theta, whoops, which we already know, becomes sine 2 theta. This guy here, minus 2 times half, sine cos. Sine cos, we're going to use this one. Sine theta plus 5 theta is 6 theta. sine 6 theta plus theta take away 5 is negative 4. Because the formula is half. Minus 4 theta. Ugh. I'm using the formula that I've circled here. Now, that becomes sine 2 theta. 2 times a half is 1, minus sine 6 theta. Negative, sine is odd. So what's sine of negative 4 theta? So that's minus sine, and then with a negative makes it into a plus sine 4 theta. Exactly as was required. So you shouldn't be looking at the math. Do it yourself again if you want to. What you should be looking at is just that first step. We said which formula is it, just do it, jump into it, those compound angles, and it shouldn't be hard. Really, it's not meant to be hard. That's like probably the 4th time we've done a similar question there. I know I did the other one 3 times. So I remember that. You guys definitely should remember it as well. Hence solve. Oh, let me just make sure it's good, if it's relevant for you. Hold on. Hence solve. Hence solve. Is it going to become D12? Let me just make sure. I don't see it being D12. Could work. That. All right, but I can't actually see the hence. Anyone see it? Anything? Can help us out? No, you're not allowed to do that individually. Stop saying this stuff. You can't do individual terms. Sides. You're only allowed to inverse full sides. Correct?
Yeah.
You can't square individual terms. You can only square full sides, let's say. Like a whole side, the whole left-hand side.
It was never
I know, but you just say you don't. Not allowed. What are you saying, Stefan?
Sine 6 theta.
If you minus it becomes back to this. But then, yeah, you'll end up with, obviously, 4. So minus sine 6 theta becomes this guy, which means you're equal to 0. So you end up with 4 sine 3 theta sine 2 theta sine theta equals to 0. Not that that's any easier, that's what I was trying to say. But it's right. It's one or the other. I'm just thinking there is no other way. That's the problem. It's something I was trying to avoid, but there is no other way. Okay, what are we going to do with that? What school are we doing? James Roos? Yeah, that's why. I was trying to avoid it. But so we're all okay with the equal to 0 bit? What are you going to do now? You can't avoid it. That's a clue. Yep, but how? You can't factorize sine because there's nothing like that. What are you going to do? Say again? Yeah. That's unfortunately what you've got to do. You've got to break all of this down. Let's go. Yeah, no, it's just time consuming. 4 is not going to do nothing, so let's just get rid of it. There it is. Go on. Sine theta plus 2 theta. Let's leave this for the time being and see what happens. Let's not break this up just yet. This guy becomes sine theta, cos 2 theta, oops, plus cos theta, sine 2 theta. I don't know if I'm liking this, but it is what it is. Cos 2 theta is 1 minus 2 sine squared. 1 minus 2 sine squared. Sine 2 theta is 2 sine theta cos theta times cos is 2 sine theta cos squared. I know it's really annoying. Sine 2 theta again is 2 sine squared theta, because sine and sine is going to get you sine squared. Cos theta. That's how dangerous to make it hard. That's all. It's not that it's actually a hard question. It's just that's going to be longer. Sine theta minus 2 sine cubed plus 2 sine theta. I'm going to change the cos squared too, because I know eventually when I want to solve, I would like everything to just be in terms of, it's not going to work out, because this is going to have a cos theta. Anyways, we'll see. We'll leave it as it is for that bit. Next bracket. Yeah, it's actually okay, I think. This one here. Sine plus 2 sine, 3 sine, minus 2, minus 2, minus 4. Let's have a look at that line. Sine plus 2 sine. It's 3. Minus 2, minus 2. Sine cubed is minus 4. Yep. I'm going to change the sine squared to 1 minus cos squared. I just changed sine squared to 1 minus cos squared, and now I've got 2 brackets equal to 0. I'm done. So I'm going to pause there first. Have a look. I was trying to avoid that, but unfortunately, I'll look at the solution. Maybe I missed something from the hence.
Sine 2 theta, sine theta cos.
Wait. Go again.
What is sine 2 theta,
This bit,
then sine theta cos, like, the second one here?
that's 2 theta, not squared.
Yeah.
Yep.
I would have to, like, place it that, like, in your mind, that would, doesn't mean you really wanted to, just make it close a minus a minus close a plus b.
Oh, change this one to causes and stuff.
Yeah.
No, why would, no. I see what you're saying. No,
Right, you're allowed to do that?
but you're allowed to, yeah. Using that compound angle formula, is that what you're saying? Right? You're allowed to change this to the half and stuff like that again, but it won't help. Oh, but maybe, no, it wouldn't have helped. It wouldn't have helped. Because you really needed powers. Because now you can factorize. What you guys need to understand is with your double angles or triple angles, you actually can't factorize your theta. I just want to see if that's the approach they took. Maybe I missed something from the hence other than the 0. So let's just make sure before I overkill it. I'm going to continue my way because I mean that's obviously my first thing that came to my head and the only thing that came to my head. But let's see if there is a different way. Oh, but of course, I didn't even see it like that. What is it? Is that what you're thinking?
No.
Just make it, I don't know why I didn't just make each one equal to 0, they're already multiplied. I'm not wrong. As you can see, what I was trying to do, it's okay, what I was trying to do is get 2 things to multiply. What I didn't realize, they were already multiplied from the beginning. That was very, very silly of me. Oh well, we all make mistakes.
Yeah, that's you.
You're so fast.
This guy.
I know, right? Audacity.
Oh my god, alright. So we're going to have sine 3 theta equals 0, sine 2 theta equals 0, and sine theta equals 0. Then you'll get your answers from this. Otherwise, I'm going to continue the way I did it as well, since I'm already bloody all the way here. Sine theta, you would factorize it out, just so for those who want to see the answer. And then cos theta, factorize it out. Sine theta equals to 0, and then 3 minus 4 sine squared equals 0. Same thing with this one, cos theta equals 0, and then 2 minus 2 cos squared equals 0. Sine squared equals negative 3 over 4, nope, 3 over 4, and then square root that, plus minus root 3 on 2, and then that should just work out. And same thing with this guy, cos theta equals to plus minus 1, and it should work out. Oh well, you win some, you lose some. I wouldn't have got it wrong. It's just unfortunately, I overkilled it by
Too much.
way too much.
1, 2, 3, 4, 5 lines.
Yeah, that's just stupid. You would never do that. It's already multiplied. We already realized the hence. We brought it over. We made it equal to 0. I don't know why I just did. I don't know why. Maybe I really wanted to expand sine 3 theta. That's all I was looking at. Oh,
That board.
I'm that bored. Doesn't matter. The answer should be whatever the answers become. Yeah. Zero, 60, 90, 120, and 180. And looks right from what I've got as well. Root 3 on 2, which is 60, 120. Yeah, like I said, you'll get the same answer, obviously, but oh well. Oh well. Oh well. Any questions? Anyone not understand what obviously what I've done or what the mistake was that I did? Really didn't work 2 marks. Okay. This is the one I believe will be in this year's exam, HSC exam. I've already told the U12s. Let's hope they study it. All right, there's your graph. 2 marks each. Do the square root and do the reciprocal. Do the square root. Oh, we already got the answers. I was like, I'll draw it graphically, but. Square roots. What do you do with the square roots? Square it over. Yeah, right. That's more just so you guys at the beginning learned the shape of it. But now I think we should know what you were doing. What happens to all of these numbers up here? Those become smaller, won't they? And parabolic, the same thing with here. What about the bottom? Can you square root any negatives? That's the answer. Are we happy with that? And what about the reciprocal case?
0, 0, 2, and with the
No, it doesn't. Goes to the top, it can't say that. It comes like that, yep. Don't forget, you're going to have this. Right, technically. So that's true, and then what? What's 1 over small? What's 1 over large? So how does it look though? Does it look like this? Does it look like that?
No, the other side.
What do you mean by the other side? This side.
Yeah, no.
Maybe you guys do it for a second. Just continue. Draw in for yourself. And then we'll test maybe Greg or Ben and see what they got as well. Actually, Nada's pretty good with this as well. Let's see. Nada, what do you reckon? What's the answer for double I? How do I draw this right-hand section?
You would put the arrows going like the up
So
thing.
you're saying it's going to look like this?
Yeah.
Isn't there a problem though?
I don't know.
Usually they look like this. But there should be a problem. And the problem is the fact that it's not a curve, it's a straight line. So it's not going to be curvy when you're just going to flip it. What should it look like? So it's going to look like this. Interesting.
I didn't know the rules on that.
You don't. The thing is, 1 over a very small number is a very large number. So it's going to start somewhere up here. And 1 over a very large is very small. So wherever it ends, have a circle. Why does it look weird to me? Hold on. Something's telling me. Problem is, it's not this way, is it? No. Is it? X is 50. 50 take away 1 is 49. 49 take away 1 is 48. No. Shouldn't really be a curve. I'm happy with it. I'll check that solution in a second.
So what's the group like?
Oh, forgot about that middle part. 1 over, well, this is -1, roughly. So 1 over -1 is still there. 1 over small, again, is large. 1 over small, again, is large. It can't be curved.
It's just one over this, isn't
If they're straight,
it? Wake up tomorrow.
they're straight lines. Yeah, they can't be curved. They can't be curved, right, Sam? No, they're not. So I'm second guess myself that I shouldn't, so I'm going to stick with that answer and we'll check it. Like I said in a second. Let me just find one for you and I'll check. Greg, Ben, what do you guys reckon? Oh, end of exam. Agree, disagree? Greg?
I wasn't too sure myself.
I think that should be right. I think so.
That's right, yes. 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 They intersect twice. What do you mean they intersect twice? Go back here. The black one?
Yeah.
They-
There's aisle in the straight one and then cuts out on one.
Yeah, that's right.
Um,
But how would it matter? Because you're going to be drawing this on separate axes. So how would you see that? Does that make sense?
Yeah.
If it was drawn on the same one, yeah, you'd go a little bit higher because the square root of numbers between 0 and 1 is bigger, and then that's the logic. So you go a bit higher and then come back down. But to you guys, like, it doesn't really matter. You're just going to draw it like that. What about double line? Let's have a look. Double line. Interesting one. Curve must show a nature of graph y equals 1 on f of x. Why don't I like the curve? Why do I feel like it shouldn't be curvy? Why did I feel like it shouldn't have been curvy? I get the logic of the infinity and everything.
What?
The only reason why it's curvy is because of the fact that it reaches infinity. But realistically, 1 over, yeah, that's not what I do. 1 over x. No, I don't know what I was thinking. Let's just clarify a few things. Again, 2 mistakes. Wow. I don't know what I was thinking. Hold on. Y equals to x is a straight line. Y equals to 1 on x, which is a hyperbola, it's curved. So I actually don't know what I was even thinking. I don't know. There's clearly something that I was thinking about, but it has nothing to do with that. So far out. What am I doing? All right. I actually don't know what I was doing there. What was I thinking of?
Sleep.
Sleep?
Yeah.
Yeah.
I would never.
Amelia's been teething. Lovely. What was I thinking? The only problem I had with this was the fact that as this is approaching infinity, this is meant to be approaching 0. And that's why I was like, oh, it's not working out because I'm stopping it in midair. But something felt right about it as well. And I don't know what I was thinking.
Felt right because it's absolute function.
Who knows what that guy's talking about? Okay, Sydney grammar. Let's go. Next. Let's not make that mistake again. Let's start at the end. Nada, you were right. I'm sorry for overriding that. Sec inverses inverse. Have we done inverse of truths like this? Yeah. Yes. Let the function be restricted. Show that the inverse is this. Hence, find the derivative of the inverse, which you can't do. So let f of x be sec x, 1 on cos, be defined for the restricted domain so that its inverse is also a function. Show that the inverse is this. Of course, you're just going to go x equals 1 on cos y equals 1 on x, and then inverse cos of 1 on x. And what would be the domain of inverse? Well, what was the range of sec? What was the range of sec? If you don't know it or you haven't memorized it, let's just quickly derive it. Cos looks like this. And it's from 0 to 90 degrees. So from 0 to 90 is right there, right there. Sec is obviously from 1 all the way to infinity. So therefore your range, sorry, your domain would be from 1 to infinity. Does that make sense? So that's your sec curve. I just quickly derived it. If you haven't memorized it, that shouldn't have been an asymptote. It continues, obviously, but find your range. Oops, what happened? Find your range, and then from there we should be able to get, there it is. Find your range. From there you'll be able to get your domain of your inverse. Any questions? That one's okay. Scroll up. Use the T formula to solve the D. I think we're fine with D. Are we okay with that? Or should we, oh, no. What's the only thing you got to do when you're solving for T? With using the T formula, there's a downfall to it. No. There is a downfall with T formula. You have to always check something. Someone tell us? You all don't know, that means you've all forgotten it. I don't know if I did with the other question either, which I should have. T formula, it has a problem because tan 90 degrees is undefined. Right? Because tan 90 degrees is undefined, when you're using tan theta on 2 as t, if theta was 180, you are automatically excluding that. You are automatically excluding that. So when you work out your solutions, you are ignoring theta equals 180. The problem is theta could be 180. So what you have to always do is sub it back into the original and test if it works. So T formula has a flaw, and that flaw would be you must test x or theta, whatever letter it is, as pi or 180 degrees. It's not flawless. Next year's method, auxiliary angles will be flawless. Okay? Auxiliary angles is just how to change from polar form to Cartesian form for square root of a squared plus b squared and inverse tan b on a. So mod form, if you remember that. Anyways.
Isn't that interesting, you know?
Yep. There it is. Oh, there's auxiliary angles right there. R is just square root a squared plus b squared, and alpha is inverse tan b on a. Those who are doing 4 unit, that should look very, very familiar. Anyways, that's how you get mod R form. Do B. 100% will be in your exam. You guys need to master it. I don't even know what I was thinking of that absolute value. I actually don't know. I'm thinking 1 over a straight line. What was I actually thinking? 1 over an absolute value of a straight line. What was I thinking? Why did I draw that? I don't know. I don't know. Start and stop. Start and stop. Start and stop. Graphs. You're just doing B. You make sure. Start and stop graphs. Let me think of some. Don't mind me, I'm just doing some stuff. Start and stop graphs. Yeah. Yeah. Start and stop graphs. You wouldn't believe the mistake I just made.
You look at the mistake I
Oh, God. I said 1 over a straight line
made. Yeah.
is a straight line. But it's clearly a hyperbola. Ah,
I got a question wrong. Whether H2O that is O2H.
Oh, yeah?
Yeah.
Yeah. Maybe it's not that big from that way. Yeah. Oh, God. How'd you find it? Sorry? You'll be surprised with how bad it is.
Yes, I'm pretty.
Nah, you'll be alright. You'll be fine. Trust me. Just keep preparing. How's the extension? What is it? Yeah, you'll be fine. Yeah. Yeah. I can say the same thing. But, I know.
That just means that you teach it understand.
Yeah, that's what I just think. God, that's not how we said it. Okay? It doesn't mean anything. It's her ability.
It also makes for teaching. Which is why you have to read it.
Can you just do it? Come on. Can I make that cloud your preparation like that? Do the same preparation. You'll be fine. I can get harder than James Bruce and Sydney Brown. You're doing it on case and papers. I don't get it. All right, let's go. But then again, see, like look at me. I did this one, involves harder stuff. And that happens. Like it's just silly. Or like this one, that was just silly as well, what I just did. And you lose a mark or two, what can you do about that? Say like, yeah, it was done and she didn't finish it. It doesn't mean nothing. Really doesn't matter. All right, here we go. You need not show this. Perfect. So T equals A plus BE negative KT as it always is. A bottle of baby milk is at 4 degrees when it is removed from a refrigerator and placed on the kitchen bench where the room temperature is 22. What equals 22? A equals 22 degrees. 5 minutes later, T equals to 5. Capital T is equal to 12. Find the temperature of the milk after a further 3 minutes. So when T equals to 8. Here we go. So when time is 0, temperature is equal to 4 degrees Celsius. Don't forget that. So 4 equals 22 plus B, E, 0. So B equals to negative 18. Yes? So then our new equation becomes T equals 22 minus 18E negative KT. Second set of conditions, temperature is 12, time is 5. Solve for K. I'm just going to do it in my calculator. I think you guys should definitely know what to do by now. 12 take away 22 divide negative 18 log divide by negative 5. I got K as 0.117556, whatever. Okay, last line. Therefore, T equals 22 minus 18 E negative 0.12 times 8. To the nearest degree, you know what, I'm going to use my exact value for K, and the answer is 15 degrees Celsius. We're good with that? Questions? All right, next one. The equation x cubed plus bx squared plus 6x plus d equals 0 has roots. Use the sum and product of roots to find the integers b and d. Oh, easy. Go. Shouldn't take you more than 90 seconds. Right fast. As fast as you can, seriously. Speed this one up. I can already pretty much see the answer for B. And for D, yeah, I'm not that far off. Telling you, use the sum and product of the roots. You're still reading. That one just quick. Alpha plus beta plus gamma. 1 plus root 3 plus 1 minus root 3 plus 4. Okay, done. So, what's your answer for B, Mariette? And D, 8, 1 minus 3. Why did I get 16? Am I wrong? Everyone got 8 as well? Wait, come on. What's wrong? 1 plus root 3 plus 1 minus root 3 plus 4 equals minus b on a, which is just minus b. These cancels out. B equals to negative 6. Then 1 plus root 3, 1 minus root 3 times 4. 1 minus 3. Again, you know what I said in my head? 1 minus 3 is 4. I'm not here today. 1 minus 3 is negative 2. Negative 2 times 4 is minus bc minus d. D equals to 8. Is that what he said? Wow. Wow. Too many mistakes for me. Non-exact gradient, polynomial has a factor. That's easy. In trying to solve this over its natural domain, alright, let's have a look what it's talking about. It's multiple choice. Alright, read. In trying to solve its natural domain, instead of real numbers, 3 students produced the following inequalities. Student 1 says to cross multiply. Student 2 says student 2 squared this side and cubed this side and then multiplied it. Student 3 went to the power of 4 for this one. No. Wait. Student 4. Student 3. Oh my God. It's not my method. It's the problem. Student 3, which would stuff me up, wouldn't it? You're gonna do it my way, and this. Okay, let's see. Well, what's happening? So you've got to understand inequalities for this. What are you allowed to do with inequalities on both sides without affecting the inequalities? That's the idea. So hold on. So this one here, you've cross multiplied. The problem with that is you can't necessarily say that this one here, student I, that this is technically correct. Because when you're cross multiplying, it's usually been for equal signs, which you could have said the right is equal to the left or the left equals to the right. You can't necessarily say this side here is less than this side. So that one's definitely wrong. So student I is definitely wrong. So we know the answer is definitely not D. Not D. Now, student double I and triple I. Let me just see what's happened here again. Triple I, that's multiplied by x minus 2 and x minus 2. Oh no, that's not, that hasn't been cubed, that's multiplied together. As long as you're squaring. All right, student 2, double I, is definitely correct. So I know definitely B is wrong. Double I is correct. Why? So what we've done to both sides is we have multiplied it by the squared term of x minus 3. So if I multiply this by x minus 3 squared, so just look, which is a technique your teachers would usually use, times x minus 3 squared times x minus 3 squared. Because you're multiplying by positive numbers on both sides, your inequalities will not change. Does that make sense? And the reason why that works out, just look at it, that and that cancels out, which is just x minus 3 on the top. Yes? Can we see that? And then here you're going to have an x minus 3 all squared. Then, and then if you times this across, well, technically it should have been x minus 2, square root of x minus 2 squared, which eventually, once you fix it up and adjust it, this would come up to here, technically. I can just see it. So student double I is definitely correct. I'm just looking at triple I now. Triple I now. Triple I now. What's happening in triple I? X minus 2 or squared x minus 3. Okay, triple I looks like it has taken double I and no, triple I is wrong. Because you've got a surd on the top here, and the only way that's going to happen is by you rationalizing. No. Oh, no, you could have multiplied it by x minus 2. That becomes power of a half. Half and 1 becomes a half. But then if you multiply this side by x minus 2, you've got to also multiply this side by x minus 2. But that's not allowed. You can't just multiply by x minus 2 because x minus 2 could be negative. So it's going to be x minus 2 squared for this to have worked out. This one's wrong. So let me tell you again what they've done for this student here. Triple I multiply, no. But it is question 10 of the multiple choice. And you, again, HSC for question 10 means just less than 6 state lane kind of style question. So it's meant to take long if you want to get it right. Back to it, times by x minus 2 on both sides. Can you see this person has multiplied by x minus 2? They got x minus 2 squared from the top here. Here, if I simplify the top and the bottom, that gets me a power of a half on the top. There it is, and there's that term. And the other one they've just multiplied by x minus 3 squared, which is right. It's the x minus 2 that isn't right. The fact that x minus 2 could be negative is a problem, because then you're multiplying by negative, which means you have to flip your inequality sign. But with the squared, it's not a problem. So the only student that's right is just student double I. So that's annoying, but what can I do? Go up. Oh yeah, that's technically allowed because part of your inverses. What is the value of inverse cos of sine A? What is the value of inverse cos of sine A? Yeah, can we avoid it? Maybe.
You don't care. You know the hypotenuse can be root 1 plus x squared.
1 plus x squared. No. You're thinking of a value of sine A or something. What is the value of inverse cos of sine A? Let me see what I would do. I would do that, yes. But then maybe sine. Sine obviously has maximum value of what? Sine A. Sine A has maximum value of, what's the maximum value that sine A can ever be? Think of your sine curve. 1. What's the minimum that sine A is ever going to be? -1. So the maximum value of sine A, so look, technically you've got this sine curve that just does this. It's telling you that alpha is between 90 and pi, right? So for your sine curve, there's 180, there's 180, there's 360. So it's telling you it's this region. So what's the largest, what's the largest sine value you're going to have? 1. What's the smallest sine value you're going to have? No, for this point here, 0 now. So you're just inverse cosing, essentially, you're inverse cosing 1 and 0. Now, which obviously becomes inverse cos of 1 is 0, inverse cos of 0 is 90 degrees. So, what's another way, Sam? Let me think. It's fine, I've got it. Let's go again. Inverse cos. How does an inverse cos look? 1, negative 1, 0, pi, oh, pi on 2, and pi. So if I'm inverse cosing every number from 1 to 0, look, if I'm inverse cosing every number from 1 to 0, can you see that? It's from there to there. What's your domain? From 0 to? Sorry, what's your range now? From if it's 0 to 1, your range is from 0 to pi on 2. Why am I not linking it together? What's wrong with me? Where am I going? I know it's not you. 0 to 90 degrees. 0 to 90 degrees. It can't be D. It can't be D because if alpha is already between 90 and 180, my range has to be between 0 to 90 degrees. So it'll be outside. Next one, alpha minus pi on 2. Alpha is between 90 and 180, minus 90, yes. 90 minus 0 is also, so it could be either of these two. So go back. Now, order.
Would C give you a negative?
Why would C give you a negative?
So if your angle was 70 minus 9.
But alpha is between 90 and 180. And what was your reason?
I didn't know. I didn't know alpha was between 9 and 90.
Alpha is between 90 and 180. Come on, all right, what's another way? Where am I going? What's another thing?
But Sam, couldn't you just use the relationship between sine and cosine as sine alpha equals cosine 90 minus alpha? And then inverse cos of cos is just the angle, so it's 90 minus alpha. And yeah. I don't know.
But, because you just said that, now I think the answer is C. Because that's only for alpha being acute.
Yeah, it is. So it's
So it'll be C.
yeah.
We have to use everything. All right. So, I know.
This is supposed to be in
I told you Sydney Grammar is harder than James Lewis.
Multiple choice.
Sine alpha equals cos 90 minus alpha, inverse cos, but when you get inverse cos of sine alpha, that's only for alpha being acute, between 0 and 90 degrees, but alpha is now between 90 and 180. I'm just not going for B, I'm just going to say the answer C, because it would have to be the other way around. We'll check the answer. It could be, it'll be funny, it could be A. So let me just finish it off. What's the time anyways? 8, let me just finish off this last one. Which is the expression? That's easy. That's vectors, slope fields. Okay, quickly, do question 2. Binomial expansion, and then I'll quickly check the answer. Question 9.